program. For that, we are plotting a for loop, that is for C. Here we are putting a variable C as a matrix form to give the input 2s/n formula. So to find the acceleration, so C is equal to 2s/1. Then we are putting here, we are going to find acceleration here, that is acceleration is equal to velocity v in a matrix form, that is C bracket complete minus v, that is velocity. Here we are using C minus 1 because the formula is final velocity minus initial velocity is equal to the acceleration. So we are dividing by 3.6. So here a total acceleration, we are noting it as acceleration, is in meter per second square. So we are dividing it by 3.6. Then we are finding a distance. So the distance is sorry friends, there is a mistake from my side. Okay, distance is D and is C matrix, then is equal to distance in, that is C minus 1, means the first iteration plus velocity in terms of matrix divided by 3.6 also divided by 1000. So we will get a distance value in a kilometer. So let's save this. Then from this point we are finding resistive forces. So guys, we are already studying about the resistive forces. So there are three types of resistive forces. First is aerodynamic drag, then second is rolling resistance, and the third one is gradient resistance, and fourth one is the linear acceleration. The inertia force we are generally considering in our end, but we are not considering the hill climb resistance because we are assuming that our vehicle is on the flat road. So for the force of resistive force of aerodynamic drag, we have a formula of half into 1.225, that is rho, into area into CD, means coefficient of drag, into a velocity, that is in, we have to put in the meter per second square. So velocity in a matrix form and divided by 3.6 for a meter per second square, the bracket complete, and we want its square. So the square point of view, then we are note it as a aerodynamic drag. then rolling resistance. For that rolling resistance we are assuming it as FRR, that is 0.02. we are already mentioned here. Okay, we are not mentioned it earlier, so let's mention it as percentage rolling resistance coefficient, that is CRR is equal to 0.202. Okay friends, so clear up to this? Okay, the main part is we have to make this rolling resistive force. We are considering here a mass of vehicle, so for that we are multiplying it by 9.81 and we can save this. Then acceleration force due to resistive force due to acceleration that is FLA we are putting here, then it is mass into the ACEL, means the R acceleration value which we have find already. So in this we are putting it as acceleration, then we are doing the sum of these values, that is PTE is equal to what is PTE? PTE is the total power so PTE is FRR plus FAD plus FLA. Yeah, clear guys? So from this we are putting up resistive forces, that is total resistive forces. So what is the formula of power? Power is a force into velocity, so we are multiplying it by a velocity. Here velocity, that is VC, so we want a velocity in a meter per second, so we divide it by 3.6. so the total power we will get in a Newton form. So we will convert this total power into a matrix form, that is in a C formation is equal to PTE. So this is the our traction power. Okay guys, then we have to find a omega. Omega is equal to grad, means the ratio of our vehicle in gear ratio of our vehicle into a velocity, that is V C divided by 3.6. So here guys we have to convert all the parameters into a meter per second, so we every time divide it by 3.6. so let's complete one loop. So here we are finding all the values in various in the mathematical way. Means in a program we are considering the formulas and put all the values in it to find out the forces. So as all the points mentioned, we are now putting a if loop for our stationary type of vehicle. So omega is 0, then we will say that the vehicle is stationary. Okay, then we will put the total traction power is 0, then our motor power, that is P, that is P motor means in power, is equal to 0. So no power into motor. Okay guys, then the torque is also 0 in this case. Percentage no torque. We have put all the calculation for the here loop for a stationary. After that we will put a loop for a moving object, means for a moving vehicle. Then else if means omega is greater than 0, then we will say that the vehicle is moving. And if the total power is greater than or equal to 0, then we will say that the vehicle is in cruising or accelerating mode. Then we will see how to calculate the motor power from the efficiency. So the motor power, that is motor output, is equal to total power which we have already find divided by the efficiency of the motor, the transmission efficiency of the vehicle is motor power is always less than the shaft power. So at the output we are getting a less power due to the transmission efficiency we are assuming. So the motor input is equal to the power of motor out divided by efficiency of the motor, which we have already put it in a input box. So this is for the motoring mode. Okay guys, so I will explain you for this. Okay, let's save this. So here what we assume, we are assuming that omega is greater than 0 for such a way the vehicle is moving, because what is the omega? Omega is 2 pi n by 60. So when the n means the RPM of the vehicle is greater than 0, we will get omega is always greater than 0. So for that we will put this all the value in such a way that we assume it as a stationary way, and we assume it is in cruising mode. So the motor output is equal to the traction power divided by the transmission efficiency. Here what we have to say that the shaft power is always less than a motor power. So for this calculation we are using this factor, transmission efficiency. Then also there is some losses in a motor, that is eddy current losses, some flux losses, there are some mechanical losses or the current losses. So for that we are also using a efficiency of a motor to get a optimal output from a motor side. So let's go to the next point, then we will end this loop. Then we have all the parameters, so we can just find a torque, that is torque is equal to P motor out, means the transmission efficiency value divided by the omega. Means what is the torque? Torque is a power divided by 2 pi n, that is omega. So power is equal to 2 pi nt by 60. So when we shift that torque into the left side and power into the right side, we will get this as a output. Then we will find out power of the battery. So for the power of the battery we are going to put one syntax for the power of the battery, that is in the matrix form, is equal to the P motor in, means the output of the motor, plus the accessories power. So we will get a total power required from a battery, because there are so many accessories, means HVAC system, a compressor. In a HVAC system we are having an electric compressor, in a steering we are having a electric motor, in a brakes we are having a electric servo motor. So all these parameter which we are driving from a battery, so there are many parameters to bring that battery consideration. As you see in our battery module concept in EV technology, these points are already covered in that. So we are considering these accessories in our battery power required from a battery side. Then the energy required to drive a vehicle for a one cycle is E energy is equal to E battery, that is C minus 1, means the another battery, and power of the battery, that is C. So it is a energy required from battery in one cycle. And what is this is power required from battery. Okay guys, so now we will again put all the parameters into a distinguished variable So we will plot them into a graph format. So for this we are putting the time, that is c is equal to a c variable, that is in the time, we will show it as time. Then a velocity is c is equal to v in c, that is acceleration c is equal to the acceleration, then p motor, then P motor means power of the motor, that is equal to the power of motor divided by 1000, it is power from motor. So I will put down all the parameters and explain one by one. So let's finish the putting ones. Omega, then T motor, distance is equal to c, that is d c, energy of the battery is c, energy of the battery, that is c divided by the 3600, means we have to convert it into kilowatt hour. So we are giving this factor and to save this. So here now I will explain what I have put. I have put all the parameters, that is first one is time, then second one is velocity, then third one is acceleration, then fourth one is power from motor, then this omega is motor speed in RPM, motor speed in RPM, then the motor torque, then the distance covered by the vehicle, and the current from the battery, Okay, so guys, from this we want all the maximum value from the among given value. So to find out the value, we are having a syntax as max. So for this we from that we can find out the maximum value easily. For the to find a minimum value, the syntax is min, and to find out the average value, the syntax is MENN, that is mean. We are doing all the work in a MATLAB software because it is very easy to identify what capacity or what motor we want to drive the vehicle. So as the all the parameters concern, as we put the all the parameters in this, we can also change the parameter and just this cycle to get various output from the program. So you guys please visit the MATLAB official site, that is mathwork.com, and do one math on-ramp course to at least get a basic idea about this programming language. So we have get all the value, and last one is the average value. So I have already explained this value is in the mean form. So I will end the cycle here, and we will put and plot all the graphs in our next chapter. So thank you for watching this. We will see you in our next class, in a next chapter. Thank you guys.